North Africa, 1942. A German ace fires into an American P-40 Warhawk, shells ripping through its fuselage, sure of a kill, but the Warhawk refuses to fall. That night, Luftwaffe reports just 2 words: Unmöglich stark, impossibly strong. For years, German pilots dismissed American fighters as crude and heavy, but something about the P-40 shattered that belief. When captured Warhawks were stripped down in German labs, the truth turned their engineering world upside down and forced the Luftwaffe to rewrite its rules of combat. So how did American design create the indestructible fighter that changed German doctrine forever? The answer begins with a clash of engineering philosophies on the blazing desert front. 1938. In Augsburg, Messerschmitt engineers finalized the Bf-109 single-spar wing, an elegant solution built for speed and agility. The design brief is clear: every kilogram trimmed, every component justified. German doctrine prizes minimalism: one main spar, stressed skin, a structure that bends but doesn't break under a fighter pilot's hand. Weight is the enemy, precision is the answer. The Bf-109's I-beam spar sits deep in the wing, forming a stiff D-shaped box. Torsion loads flow through the aluminum skin, not redundant beams. For German designers, efficiency is strength. Across the Atlantic, Curtiss engineers see a different threat. American planners demand a fighter that can take punishment and fly home. The P-40's blueprint calls for 5 wing spars, steel and aluminum running tip to root. Each spar shares the load, each one a backup if the others fail. The airframe grows heavier, but the gamble is clear: survive hits, keep fighting. Curtiss doesn't chase the last ounce. They build for the unknown: the stray bullet, the rough landing, the sand-choked airfield. German test pilots trust their machines to hold up in a clean fight. The Luftwaffe's confidence rests on numbers: turn rate, climb, acceleration, all measured in controlled conditions. Their doctrine assumes the first pass decides the duel. American engineers, meanwhile, prepare for second chances. Redundant systems, armored cockpits, self-sealing tanks, features that add weight but save lives. On paper, the two philosophies barely speak the same language. One side trusts in precision and speed, the other in brute resilience. By 1942, these rival doctrines meet in the desert. What looks crude to a German engineer, thick spars, heavy skins, proves stubbornly hard to kill. The P-40's 5-spar wing isn't just a structural choice, it's a bet that in war survival matters more than elegance. June 1942. The North African desert is littered with the wreckage of burned-out trucks and twisted aircraft frames. Amid the chaos, ground crews at Gambut count bullet holes in the P-40's limping home. One Warhawk lands with its left aileron missing, hydraulic fluid pouring from its belly, and more than 50 punctures through the wings and tail. Mechanics shake their heads, expecting the worst, but the engine still turns over. The pilot, pale and sweating, climbs down and reports that the controls held firm the entire way back. Across the airfields, similar stories surface. Flight Officer Jacklin brings his P-40N home with a quarter of its left wing gone. Over 200 miles flown with the control stick vibrating in his hands. Another pilot returns with the canopy shattered and the main spar gouged by cannon fire, yet the structure holds. Debrief logs from No. 3 Squadron record 6 aircraft returning in a single week, all with heavy damage, none lost to structural failure. Luftwaffe squadron leaders, reviewing their own after-action reports, note the pattern. Bf-109 pilots claim direct hits, but the same P-40s are spotted strafing convoys the next morning. German observers begin to question the numbers. How many Warhawks are they really downing? At staff briefings, frustration grows. The standard attack runs, so effective against Hurricanes, don't guarantee a kill. One commander writes, P-40s with holes in both wings continue to fly. Armor must be improved. The mystery deepens with every sortie. British and Australian pilots, battered but alive, start to believe in their machine's resilience. German intelligence officers, sifting through wreckage, find wings torn open but spars intact. The old assumptions about American engineering, clumsy, overbuilt, no longer fit the facts on the ground. Reports pile up, Warhawks shot to pieces, refusing to die. The need for a technical explanation grows urgent. Burma, 1941. Claire Chenow's American volunteer group, better known as the Flying Tigers, arrive in battered P-40s, facing Japanese pilots who expect easy prey. But the first dogfights rewrite the script. Chenow drills his pilots in diving attacks, using the Warhawk's weight and rugged frame to slash through enemy formations, then climb away before the nimble Ki-43s or Zeros can react. The AVG's tactics are brutal and simple. Never turn, always dive, hit hard and get out. The results are staggering. In just 7 months, the Flying Tigers claim 297 Japanese aircraft destroyed, losing only 14 pilots in aerial combat. Their kill ratio, 25-1, becomes legend. Across the Pacific, P-40s fly from Port Moresby to Guadalcanal, escorting bombers, strafing airfields, and defending outposts under siege. Mission reports from the Southwest Pacific Theater tell of Warhawks limping home on shredded wings, engines coughing, fuel tanks holed by cannon shells, yet still making the runway. Ground crews patch bullet holes with tin and canvas, send the fighters back up the next morning. In the Solomon Islands, pilots trust the P-40's steel backbone to survive ground fire and mid-air collisions that would snap lighter airframes in two. The pattern is unmistakable. Whether flown by Chennault's mercenaries, Australian squadrons, or US Army Air Forces, the Warhawk's toughness is more than desert myth. It's written into victory logs and after-action reports from China to New Guinea. Survivability isn't a regional fluke, it's the aircraft's signature. The story of the P-40's resilience is global, setting the stage for a closer look at what made this machine so hard to kill. Curtiss engineers, working from blueprints in Buffalo, built the P-40's wing around 5 main spars, each one running the full length from root to tip. This wasn't just a matter of adding extra metal. Every spar shared the load, spreading stress across the entire structure. In combat, that meant a P-40 could pull 7.5 Gs without the wing folding or twisting. The design gave pilots confidence to yank the stick hard, banking away from cannon fire or diving out of danger, knowing the wing would hold together even under punishment. The 5-spar system wasn't just about brute strength, it was a hedge against the unknown. If a cannon shell ripped through one spar, the other 4 kept the wing intact. Mechanics in North Africa learned this firsthand. After a mission, they'd peel back the skin to find spars dented, sometimes split, but the overall structure still doing its job. This redundancy wasn't common in fighter design. German engineers favoured a single, heavy spar, lighter, stiffer, but with no backup if it was hit. Curtiss gambled that in real war, survival meant planning for what couldn't be predicted. Fuel protection followed the same logic. The P-40's tanks weren't just metal cans wedged between spars, they were lined with layers of rubber and treated fabric. If a bullet punched through, the material would swell on contact with fuel, sealing the hole and stopping a fire before it started. This self-sealing system, tested in American labs and rushed into production by 1940, gave pilots a fighting chance. In the desert, where tracer rounds and ground fire were constant threats, it meant the difference between bailing out over enemy lines and limping home with a tank full of holes. Curtiss engineers didn't chase theoretical perfection. They made choices that added weight and complexity, betting that durability and repairability would matter more than a few extra knots of speed. In the field, those choices showed up in battered P-40s that kept flying even after taking hits that would have grounded lighter, more elegant machines. The Warhawk's strength wasn't just in its numbers, it was in the invisible backups built deep into its frame, ready to take over when the fight got rough. A P-40 on a low-level pass unleashes a 6-gun burst, every .50 caliber round converging in a tight pattern ahead. American gunnery manuals call it the 11-pound wall. That's how much lead a Warhawk can throw in a single second. German pilots flying Bf-109s are used to scattered fire. A pair of machine guns above the engine, a single cannon firing through the propeller hub, sometimes a pair of wing guns. But when they close head-on with a P-40, the concentrated firepower is overwhelming. Hits land together not in a loose spray, but in a focused storm, punching through cowlings and wings before a pilot can react. Armor placement reveals another difference. Curtiss engineers bolt steel plate behind the pilot, wrap engine cowlings in protection, and reinforce coolant lines running under the floor. German designers, chasing every ounce, shield only the cockpit. The rest is left exposed. P-40 pilots know they can take a hit in the engine or belly and keep flying, sometimes leaking glycol, but still in the fight. Bf-109 pilots taking a round to the radiator or oil system face quick engine failure. The logic is simple: protect the systems that keep the airplane flying, not just the man at the controls. Desert sorties turn theory into hard numbers. In a single week, mechanics count over 300 bullet holes patched across a squadron's P-40s. Yet the aircraft return day after day, engines still running, guns still loaded. Reports from the front describe Warhawks limping home missing flaps, with control rods shot through, even with landing gear jammed by shrapnel. The pilots climb out shaken but alive, their machines battered but ready for another mission after a night's work with hammers and sheet metal. On the offensive, that firepower gives P-40 pilots options. A head-on pass isn't a gamble, it's a calculated exchange. The Warhawk's 6 guns, all wing-mounted and harmonized, can rip through a target in less than a second. German pilots facing that wall of lead begin to rethink their approach. Some start to avoid frontal attacks altogether, warning each other in debriefings about the P-40's withering fire. The old doctrine, close fire, break away, no longer guarantees survival. Now every attack comes with a risk. One misjudged angle and the Warhawk's guns deliver a lesson in American overkill. The result is a new rhythm in the air war. P-40s press attacks on convoys and columns, shrugging off ground fire that would cripple lighter fighters. In the sky, their concentrated bursts force German pilots to brake early or risk a direct hit. The Warhawk's reputation grows, not just as a survivor, but as a hunter with teeth. And behind every battered airframe, there's a pilot who knows his odds just got a little bit better. At Rechlin, the test rigs groan under the weight of a captured P-40 wing. German engineers in white coats, accustomed to the precision of their own single-spar designs, watch as the American structure endures load after load. The numbers come back from the instruments, 7.5 Gs, then 8, then higher. The wing flexes but refuses to fail. Metallurgists cut samples from the spars and run them through tensile machines. The readings show a steel alloy with a yield strength far above the Luftwaffe's standard, a composition that resists both stress and corrosion. Lab notes record that the American spar absorbs shock in a way their own duralumin can't match. One engineer sketches the 5-spar layout in his notebook, tracing load paths and redundancy that seem wasteful on paper until the data proves otherwise. Microscopes reveal a grain structure in the American steel that holds together even when gouged by cannon fire. The German team compares these findings to their own Bf-109 wing, noting that a single spar, once compromised, offers no safety net. The P-40's overlapping spars distribute the blow, preventing catastrophic failure. The lab's final report lists a G-load threshold that exceeds what frontline pilots ever thought possible for a mass-produced fighter. The results circulate through technical offices in Berlin, raising uncomfortable questions about the cost of efficiency. For the first time, the phrase overbuilt shifts from an insult to a grudging compliment. The numbers from Rechlin leave no room for debate. The Warhawk's toughness is no myth, and its engineering is anything but crude. September 1943. Luftwaffe Bulletin T9/43 lands on squadron desks across North Africa and the Mediterranean. The language is blunt. Frontline pilots are ordered to avoid head-on attacks against P-40 formations. The directive doesn't mince words. Too many aircraft lost, too many pilots wounded or killed by concentrated American fire. The Warhawk's 6.50 caliber guns, harmonized to converge at 250 yards, have shredded enough Bf-109s to force a tactical retreat. Training officers gather flight leaders for urgent briefings. The old doctrine, close fast, fire, break away, no longer applies. Instructors underline the new rules. Attack from above, never from 12 o'clock. Deflection shooting replaces frontal passes. Some pilots bristle at the change, veterans who built their reputations on aggressive dogfighting. But the casualty lists are hard to ignore. Mechanics patch holes in armor plating, count the cost of each failed engagement, and quietly pass stories between hangars. Another ace forced to bail out, another rookie lost on his first sortie against the P-40 wall of lead. The directive's impact spreads beyond tactics. Flight schools revise gunnery courses, emphasizing energy fighting and slashing attacks. Technical officers circulate evaluation reports. Reverse engineering efforts have failed to replicate the Warhawk's firepower convergence or redundant hydraulics. Engineers admit, in private, that American steel alloys withstand punishment their own airframes can't match. The sense of resignation grows. The P-40, once dismissed as crude and heavy, now dictates the terms of engagement. German pilots adapt, but the initiative has shifted. Every operational order, every new training manual carries the unspoken admission: the Warhawk has changed the rules. Curtiss factories in Buffalo run day and night. By 1944, more than 13,000 P-40 Warhawks have rolled off the line, an industrial feat that leaves German planners reeling. Each Warhawk assembled in hours, not days, thanks to a workforce that numbers in the tens of thousands. Riveters, machinists, and inspectors move in rhythm, turning out fighters at a pace the Luftwaffe cannot hope to match. Every finished P-40 is stamped, tested, and shipped to a front. North Africa, China, the Pacific, even the Soviet Union. American production lines don't just replace losses, they flood the skies. While German factories struggle to repair bomb damage and source critical metals, US assembly plants deliver new aircraft faster than the Luftwaffe can shoot them down. Warhawks arrive in crates, are unboxed on dusty airstrips, and take flight within days. The War Production Board tracks every unit. In a single month, Curtiss delivers more fighters than all of Germany's manufacturers combined. The numbers tell the story. For every P-40 lost in combat, another waits in a railcar or on a cargo ship, ready to fight. American industry turns steel and sweat into endurance, making the Warhawk a weapon of attrition as much as engineering. Redundant systems, once considered a luxury, now set the baseline for military aviation. The P-40's legacy lives on in every checklist for modern fighter design, where backup hydraulics, dual electrical circuits, and fail-safe controls are no longer optional. Today's jets, built to EMIL STD requirements, carry the same philosophy that guided Curtiss engineers in the 1940s. Never trust a single point of failure. When a modern F-16 loses primary hydraulics, a backup system keeps the pilot in command. If a fuel line is punctured, automated shutoffs and self-sealing tanks limit the damage. These standards, now written into the DNA of every frontline aircraft, trace a direct line back to the Warhawk's five-spar wing and its field-proven toughness. Aviation historians have re-examined the P-40's record, moving past old stereotypes of brute force and crude design. What once looked like over-engineering now reads as foresight. The Warhawk's blend of survivability and repairability shaped not just a generation of fighters, but the very definition of combat readiness. Engineers and pilots alike recognize that the lessons learned in the desert and jungle, redundancy, resilience, and respect for the unknown, remain as relevant today as they were 80 years ago. By the end of 1943, over 13,000 P-40 Warhawks had rolled off American assembly lines, more than double the annual fighter output of Germany. German Rechlin test reports confirmed the P-40's five-spar wing withstood stress levels their own designs could not match, and metallurgical analysis documented American steel alloys as 40% stronger than German standards. The Luftwaffe's Directive T9/43, forbidding head-on attacks against P-40s, stands as written evidence of a tactical shift driven by hard battlefield experience. Yet, not all Rechlin findings were declassified, and the full extent of German attempts to copy American redundancy remains partly sealed. Today, aviation engineers still cite the P-40's structural principles, redundant systems and armor protection as the basis for modern combat aircraft standards. The documents, test data, and frontline accounts make one truth clear. What some dismissed as crude American overbuilding became the benchmark for survival. In the words of a post-war German engineer, found in Allied interrogation transcripts, we learned to respect the strength we once underestimated.